Welcome to Probability. Mr. Mills, thanks for making these videos. They're so awesome. I listen to them all day. This is what I fall asleep to. Maybe, maybe not. I don't know. But hopefully they're helpful, all jokes aside. So in section 5.1, we talked about probability, just very, very basic stuff with probability. We learned about the law of large numbers, and we talked about simulation, which is a difficult concept. So imagine flipping a coin. You flip it once, it's heads. So we're not going to say 100% of the time this coin is going to come up heads. We start flipping it more and more and more and more. 22 tosses starts leveling out. We do this over 500 tosses. It's going to get closer and closer to 50%, assuming it's a fair coin. That's this idea of law of large numbers. As I do more and more trials, the probability is going to approach its real value. Probability is going to be between 0 and 1. It just the likelihood that your certain outcome occurs, whether it's flipping heads or rolling a dice and getting 4. The probability of something that's impossible, 0. Probability of something that's certain to happen, 1. Let's get into this. Okay. So there's something called the law of averages that is false, absolutely false, but society believes it to be true. Basically, if something hasn't happened in a while, it's going to happen. If you're watching a basketball game and one of the players, he or she has missed a few shots in a row, they might be like, oh, so-and-so's due to make a shot. Or in baseball, they haven't gotten a hit in a row. Oh, they're due to make a hit. No, not true. Because each trial is independent of the next. If I haven't flipped heads in a while, I'm not due to get a heads. Like every flip is independent of the next. All right, simulations. We walked through a 4-step process when we did this, and this was your state, plan, do, and conclude. There's a lot here. I'm not going to go through this specifically. You may want to look back at this. State was just state the question of interest. The plan was the really difficult step, I guess, if you will. So I do want to kind of break that down a little bit. So for the plan, there's a couple things that you need. Say you have 25 students in a class. So I might say like I'm going to do it this way. 1 to 25 represents the students, and 26 to 99 and 00, I'm going to ignore repeats. So say I have a class of 25, I'm selecting 3 people are going to be a winner of a $5 Starbucks card. Okay. So what I'm going to do is I'm going to look at 2-digit numbers on a random number table until 3 numbers between 0, 1, and 25 are selected. Record how many times all 3 people are male. Okay, so say that 0, 1 to 10 are male and 11 to 25 are female. And people think, oh, the males just keep winning. It's not fair. All right, so let's look at a random number table. 55, ignore. 58, ignore. 89, ignore. 94, ignore. 04. 04, that's a male. 70, ignore. 10. 10 is a male? Yes. The next one, 95, 43, you can't see that. 35, okay. 17 is the next. 17, female. All right, so if I want to know what's the probability that they're all male, that's nice. I just moved my paper too. Okay, so this would be no, not all 3 are male. And then I'd go through a few trials, and then at the end I'd say something like, according to the simulation, the probability that all 3 students who won are male is, say, 1 out of 3 times that happened, 33%. Obviously, I know I've only done 3 trials. This is not the law of large numbers, so it's not going to be a really accurate probability. But that's really what I'm going through when I'm talking about a simulation. So that's really it for section 5.1. Hopefully this was helpful.